Hello, this is Dr. Matthews again, and we're going to talk about the control of microbes through physical and chemical methods, how to get rid of them in your environment. Okay, things to consider is what are you treating? Are you treating a concrete floor or are you treating the dinner table? You don't want to put a highly toxic thing on your dinner table. The environmental conditions. The hotter the water, the better things are going to work. And that just is, everybody has figured that out. That's why you wash dishes with hot water. And what the organisms are susceptible to. If you have a really seriously hard to kill organism, you have to be sure that you use something that will kill that organism. Okay, resistance of microbes. Some are the ones that are least resistant to being killed are most bacterial vegetative cells, fungal spores, hyphae, yeast, protozoans, and trophozoites. A little more resistant might be fungal sexual spores, protozoal cysts, some viruses, Pseudomonas, certain staph species, Mycobacterium, this tuberculosis. Things that have endospores are extremely resistant to being killed in the environment. And of course, prions are just almost unkillable. Endospores are the most resistant microbial form. And getting rid of things with endospores is going to kill all organisms in that area. Cysts that some microorganisms have can also make them hard to kill. And these are going to be protozoal organisms. Prions, I said they're impossible to kill. You can kill them in the environment, but it takes chemicals to kill them. Okay, terminology. Sterilization. You're getting rid of all life. And this is going to be getting stuff hot enough. There's nothing left. You would take your surgical instruments must be sterile. You're going to have to run them through an autoclave. Commercial sterilization, temperatures that kill all living microbes, but they can also degrade the quality of the food. Just enough heat is going to be used to destroy Clostridium botulinum. Canned green beans, non-acidic soups, these are just love to grow Clostridium botulinum, and we don't need to get botulism. Just a note, if an entire family comes in with a flaccid paralysis after eating a dinner together, think botulism. Disinfection is destruction of vegetative microbes using chemicals or physical, good old elbow grease scrubbing. And this is for inert substances, floors, chairs, tables, dishes perhaps. If you are attempting to disinfect living tissues, it's called antisepsis. Degermination is to mechanically remove most of the microbes in a limited area. Like you want to degerminate your hands when you wash them. Sanitation, reducing microbes to a significant number to prevent disease. Like your dishes. There used to be a restaurant in Thomaston that I used to go to. It's notably been closed for many years, but every now and then it had a buffet. They'd bring you out plates for refills, and they'd be stuck together with cheese. And so I had my the health department environmentalist on speed dial, and he'd come down there and shut them down, and eventually they got shut down permanently. They weren't cleaning their dishes. It's really frightening. Pasteurization is used to kill vegetative bacteria. Now, it doesn't absolutely kill everything. If you take milk, even that's been pasteurized, and set it out on the counter for a week, it's going to be bad. But if you put it in your refrigerator and use it by the use-by date, it will stay good. It kills most everything. Microcidal agent is something that destroys the microbes, be they bactericidal, fungicidal, virucidal, it kills them. Microbial microbiostatic. It just stops the growth. Bacteriostatic, fungostatic. So static stops growth, cidal kills it. Okay, when thinking about is the goal disinfection or sterilization? You think about it, you're going to use this item again, and if you are going to reuse stuff, what temperature can it take? Some of the endoscopes can't take the autoclave temperature, so they have to use chemical or I think use some kind of gas disinfection. So it's not the same as autoclaving. Will the treatment leave undesirable residue? If you clean them chemically, are they going to have something yucky? And here's the problem: biofilms. If you're cleaning something that has a biofilm, it's going to take more trouble. And is it worth doing? Now, this is something really important if you're ever working in central sterile, whether that's your goal or whether you end up there for a day. You've got to remove all blood, yuck, and stuff off your surgical instruments, because if you still have some organisms, they will develop a nice biofilm that may survive some things. Some prions, for instance, may survive the autoclaving. Physical methods, most of this is going to be temperature. And the thermal death point is the lowest temperature, which kills all microbes in a liquid in 10 minutes. Thermal death time is how long it takes to kill them at that temperature. And generally in 10 minutes it would have to be a pretty high temperature to kill them in a liquid. This is showing optimum temperature of microbes. These hyperthermophiles are not going to be easily killed off. These psychrophiles are not going to be killed by sitting in your freezer. Something to think about. Dry heat. Do this in a lab. If you have a loop you're going to use for something, you flame it. You hold it over a fire until it turns bright red, and you're going to get rid of the germs on it. Incineration is another way, and this is what is done with a lot of your disposable gowns, caps, your gloves. They're going to go, if they're bloody, they're going to be incinerated. And then inoculating needles for using in a laboratory. Generally, you're going to use a flame, somehow infrared incinerators. Moist heat requires specialized equipment, and it has to require lower temperatures and shorter times than dry heat. And there are different methods available. Steam under pressure. This is an autoclave. It can also be your grandmother's pressure cooker. And now, what are those newfangled pressure cookers? That's steam under pressure, the electric ones. I think I have one, something pot. I forget what they call them because I don't really cook, but it's a steam under pressure, and you can kill germs on instruments much faster and much more completely. Because remember, if you only boil your instruments, you're not getting rid of anything that has endospore. And endospores include clostridial organisms, which includes gangrene. And you don't want to give your surgical patients gangrene. Autoclave steam heats to 121 Celsius under pressure, 15 pounds per square inch above normal pressure, and generally 20 minutes. Things like heat-resistant materials, surgical instruments, glass. Be careful when letting it cool. If you autoclave glass, you don't want to just take it out and set it on the cold table, obviously, because it'll break. Some of your media that you used to grow things in, all surgical instruments, are going to be autoclaved. Flowing steam is for substances that can't withstand the high temperature of the autoclave. and they subject to intermittent sterilization. It's called tyndallization, free-flowing steam for 30 to 60 minutes. And it's just going to reduce the sporulating bacteria. It's not going to replace your autoclave. Spores, some spores are going to survive, some are going to germinate, and so you're going to have to redo this every few days if you're trying to keep something relatively disinfected just with steam. Boiling water for 10 to 15 minutes is going to kill most everything, except for it's not going to get rid of endospores and prions. 30 minutes will kill most non-sporing pathogens. And even tuberculosis, bacillus, staph. If you have unsafe drinking water, that is the #1 recommendation, is to boil it. I know somebody who has drinking water from their well that's sandy and funny tasting, and he actually has a little still. He distills it, he boils it, and then captures the water that runs off. It's used to disinfect utensils, bedding, and back when my grandmother was a young woman, and even when my mother was a young woman, it was not uncommon to have a big pot that you just boiled clothes in to be sure you got rid of the germs. Once the germ theory of disease hit, just a little after the 1900s, it became popular. People went crazy with things. I know even in the 70s, my grandmother would pour boiling water over the dishes, even if they were going in the dishwasher. She'd scrub them thoroughly, pour boiling water over them, then put them in the dishwasher. Refrigeration. Cold temperatures are only bacteriostatic. They slow the growth. If you don't believe this, put something in your refrigerator, forget about it, come back in about 3 or 4 weeks, and you're going to have all sorts of amazing things that grow. But it does slow things and preserves food for quite a while. Freezing does slow bacterial things from growing, but some bacteria, viruses, and tapeworms, like if you have meat that's contaminated with tapeworm larvae, you can get, or eggs, they can survive frozen for days and months, so in the freezer. So you really want to cook this meat after you get it out of the freezer. Slow freezing, you're going to get ice crystals, and that's what happens when you to your ice cream. We say it gets whiskers growing on it, but it does puncture cell membranes, so it may kill more germs, but it doesn't make your food better. Quick freezing, many microbes can survive ultra low temperatures for years, but if you're trying to store bacteria or viruses, or for that matter, sperm, ovum, embryos, they're going to quick freeze them and store them so cold it's unreal, and then thaw them out and they'll still be alive. But you can't slow freeze these organisms because ice crystals destroy them. Desiccation, drying stuff out. I put beef jerky down here. It inhibits microbial growth. It is not necessarily something, I don't know, some people love, my family loves beef jerky, and they were talking about making deer jerky, and I said, think of all the pathogens that might be in those deer. What if desiccation doesn't destroy them? They look at me like I'm crazy, but I just don't like it. But it's been used for many, many years, and it sure beats nothing. Lyophilization is freeze drying, and it is used to actually preserve microbes and other cells for years, to actually preserve the organisms so you can get them back out and use them. So it's not really necessarily the greatest thing. Osmotic pressure is used to preserve foods, high salt or high sugar concentration. This has been done for many, many generations. People salt meat, and I don't know if you've ever had salt cured pork. to me it was like really bad, but some people just love it, and you may see it in the store. It's not even stored under refrigeration. And we actually have an old building that we're told is a smokehouse. It's just got junk in it now, where they used to salt meat down and then smoke it and sell it to people. Okay, high sugar concentration also preserves food. Now you're getting up my alley, not to preserve hams and meats and things, but jellies. Yum. That preserves fruit where you can eat it later. Radiation, of course, this is going to be controversial, and it's going to depend on whether it's ionizing or non-ionizing. And the effects of radiation are going to depend how effective they are. It depends on how long they're irradiated, distance from the source, whether they're shielded from radiation, and whether the radiation can penetrate the food or the whatever. We're not talking just about food, we're talking about instruments, whatever. Gamma rays deeply penetrate something, but they require long exposure. Electron beams will kill microbes quickly, but they don't go through thick stuff. X-rays are not really effective for microbial use. You'd have to use them forever. But this non-ionizing radiation is actually used in some things, such as like UV lights are used for water sterilization or disinfection. First you have all your filters and things, but then you run a pipe of water through a UV light. This is used often actually in aquariums. I've never gotten around to buying a UV light for aquariums, but it destroys algae and bacteria that go through it to keep the water a lot cleaner, and that's for drinking water as well. Visible light, it may kill some germs on the surface of things. Infrared radiation, microwave does not kill the microbes directly, but any moisture in there is going to be heated up and it's going to kill stuff. And then radio waves, I'm not sure what they're used for as far as instrument sterilization, but they are used to destroy tissue in living organisms, such as if you have a tumor or say you have a prostate tumor, they can direct radio waves at it. Or if you have a defect in the electrical system in your heart, radio frequency waves can go at that, be aimed directly at the bad spot and kill it without destroying any other tissues. Cool little trick. Filtration, and this is extremely important. First, you've got what it does, it mechanically separates solids from liquids or gas, and what it gets rid of is going to depend on the pore size of the filter, size of the molecules, and whether you're just using gravity or if you have a vacuum on it. When some of my kids went camping with a group, we bought a filter system that would filter out Giardia and other organisms, because there was no way they were going to have anything to drink out of except streams for quite a distance, and so they survived and no one died. It apparently filtered them all out. Here you show somebody filtering something through whatever this filtration system is into this jar. Okay, factors influencing antimicrobial effectiveness: population size, how many bacteria are there, composition, duration of exposure, and here's a big one, biofilms. It's a whole lot harder to get stuff clean that's already got a biofilm on it. If you clean things on a regular basis, they're going to be a lot easier to clean because of this whole biofilm thing. Concentration of the chemical agent, temperature, and how much organic matter is on it. Organic matter messes up the whole works, decreases the effectiveness of your antimicrobials. Okay, this is a thing used, they use the same type of thing to test antibiotics, but they're using it on particular bacterium to see what disinfectant will work. And so they have spread this entire plate. I think I ought to get this. They've spread this entire plate with bacteria with the lid just tilted up. And then they put different disinfectants on them. And then they put them in the incubator. And as you can see, nothing grew around any of these, though this has a wider range of effectiveness than this one does because bacteria got closer to this. So if this is Clorox, it works better. Lysol and Clorox are pretty much go-to for household things and for floors in hospitals and things. The problem with Clorox is the fumes it puts off are very caustic and harsh and can hurt people's sinuses, nose. You can get them in your eyes. Any disinfectant you get in your eyes is a problem. Okay, and that was your zone of inhibition, and it just depends on chemical use, organism use, and then how long you incubated it and in what conditions. Okay, phenols, carbolic acid, they disrupt cell membranes of pathogens, and all other disinfectants are compared to this one. They kill stuff even in the presence of vomit, feces, saliva, and pus. Sounds like a great thing. They have a very harsh odor, intense irritation to skin and mucous membranes. So they're really not something one can really use in a patient room with a patient still in it or with a human without specialized equipment. You can use it in drains. This says animal quarters, not in my place. You cannot put an animal in a place that has something very caustic. You can clean out the drains and things with Lysol, some of the quaternary ammoniums, or I don't know if I said Lysol or Clorox, but all those, and rinse them thoroughly and let them dry thoroughly. But animals are just like you. They cannot stand to have stuff burn in their nose, their little feet, and if something does burn their feet, they're going to lick it, which makes things worse. Halogens. These are reactive non-metal agents. Iodine, betadine. They use betadine, a solution of betadine, before surgery. When you come out of surgery and you've got red stuff all over you, that's leftover betadine. Chlorine has been used as a disinfectant for more than 200 years, which is interesting, especially considering how few people even believed in germs 200 years ago. But Clorox, and again, very caustic. Bromine can cause allergic reactions. Fluorine. They actually put fluoride in most city water in the United States to help teeth. There is a slight need for small amounts for teeth to be strong. In the UK, it's considered to be a horrible toxin, and they do not put fluoride in their water. Fluoride is just an ion of fluorine. And they say that we're horrible. However, just take a smiling contest and you'll see that we have better teeth as Americans than people in the UK do, as a rule. Not everybody. Some people do brush their teeth with fluorinated toothpaste, which I certainly do. Alcohols are used to kill germs. Bactericidal, fungicidal, virucidal. All these hand sanitizers, or most of them, are going to be alcohol-based. Now, ethanol is drinking alcohol. Now, if you go in the store and see ethanol in a bottle that's in the pharmacy, it has been denatured, as has isopropanol. And that means they put a chemical in it that will make you violently sick. Ethanol is easy and cheap to make. It's just a matter of they have to pay the liquor tax on it. So that makes the price higher. And just rubbing alcohol, isopropanol. And these are very effective. We keep some in our car with all this virus going around, and if we've been somewhere that might be germy, we'll spray our hands off before we get in the car and rub them together and probably choke half to death off the alcohol when we get in the car. Surfactants. This is soaps. They reduce surface tension and allow basically the cleaning to be more effective. And what a soap does is it has one side attaches to grease, one side attaches to water, so it makes it easy to detach them from surfaces. Try washing a greasy dish without soap and then with soap and see which works better. Soaps and detergents are very good for getting rid of germs. They don't necessarily kill the germs, but if the germ is down the drain, it doesn't matter. Quaternary compounds, quaternary ammonium compounds, these are very popular in detergents for microbial control. Colorless, tasteless, harmless to humans unless it's in high concentration. They're not effective against naked viruses, mycobacteria, and endospores. Heavy metals, not something you want to do at home. Mercury, silver can be in some surgical dressings. Copper is used in fish tanks, so I have seen the fish roll over and die right after using it. The one thing that I would ever use copper for, and I'm using it right now, I have a horse that's got an infection at the bottom of his hoof, and the hoof is made out of nail type material, and it's been so wet that they sometimes get, we call it thrush. It's not the same as a candida. It's they changed the genus and species. It used to be Sporophorus necrophorus, but they changed the genus on me, so I'd have to look it back up. But you pour copper naphthenate directly, clean the foot out, pour copper naphthenate on it and hold it, and it will kill the germs directly on the surface. And I also have the horse on systemic antibiotics because I really, really want that horse to be okay. He's not lame now, but you can still tell he's a little sore when you poke at it. Alkylating agents, there's a lot of diverse chemicals, very toxic. Aldehydes, formaldehyde, butyraldehyde. They use these to stop the germ growth in humans when they inject them in their bloodstream to preserve them for the funeral and burying. Also use them in animals. And the fumes are not good for you. And so I've noticed since we've been doing this online stuff that I actually have a sense of smell. I was so surprised. I haven't had a sense of smell for years because of constant exposure to formaldehyde. It's really bad for you. Ethylene oxide is for special sterilizers. Very toxic, explosive, hazardous. Don't try this at home. Food preservation. Many techniques used to prepare food, treat food, slow down spoilage, prevent foodborne illness, and still make the food have its nutritional value. A lot of things you can lose most of their vitamins. Cooking at high temperatures, you lose a lot of your vitamins. You certainly lose the texture and flavor, but you can still eat them next winter. Pasteurization, just enough heat to kill microbes that are going to cause the food to spoilage without destroying the flavor and food value. Just under boiling. But if you don't keep those refrigerated, milk for instance, it's going to still spoil. Types of pasteurization: high temperature, short time. This is batch process or a continuous flow process. It may run through a thing that processes, just a column of milk and dumps it into the truck. And then high temperature, ultra high temperature. This is stuff that can be stored at room temperature, like little bottles of ready to drink protein drink. They've got milk in them. I live off these things. I eat them drink them for breakfast every day. And you put them in the refrigerator and then you can stand to drink them. But they live forever. They're sort of scary, but they've been high temperature to kill everything. Other methods, pressure canning. This has to be done properly, but is done all the time. Any candy, food you buy are pressure canned. Food irradiation. We were going to go on a 6 weeks long vacation years ago, and I had bought some apples and I forgot them. They were in the back of the refrigerator, and I got back and they looked as good as the day we left. I cut one open. It smelled as good as the day we left. I tasted it. It was perfect. It said product of France. Well, France apparently irradiates the surface of their fruit to kill, it's a non-ionizing radiation, to kill molds and things that cause spoilage. So they stayed good. And it really would prevent a lot of food wastage if we did that. Drying is, I mentioned jerky, but drying apples, oh, those are so good. All those dried fruits, really high calorie too. And now they have special, in fact, we've got a little food dryer. We used to have an apple tree, and we'd cut up the apples and coat them with sugar and lemon and things and put them in the little dryer, and they were just absolutely delicious. Usually I couldn't even get them jarred up, refrigerated, or frozen because people ate them so fast. My aunt used to lay her apples to dry out on the hood of her car, and flies got all around them, and she says, "Oh, the sun will kill the germs." I didn't eat her apples. They were probably fine, but they were scary. If we freeze food, pickling. Now think about what makes pickling be a food preservation. It's all that salt and the vinegar. Vinegar is going to prevent things like Clostridium. The salt is going to keep most everything from growing. Curing hams, they're cured with salt and sugar, and it prevents their food from rotting. Fermentation. How about beer, wine? This is keeping your grapes good long term. Jams, jellies, and marmalades. These are high sugar, fruit sugar and pectin is what they're made out of. And they last quite a while. If you leave them sitting out on the table, they will eventually rot and die, but they're actually really good to eat. Okay, that's all for this slide.